Hello and welcome to this video where we're going to learn how to solve nonlinear simultaneous equations. Chances are if you've chosen to watch this video, you can already solve a simultaneous equation that looks like this. This is an example of some linear simultaneous equations. The reason these are linear is because if you draw their graphs, they form two straight lines. If you solve these equations using algebra, you'd end up with the solution x equals 2 and y equals 2. Notice how also their graphs cross at this point here, which has coordinates 2, 2. So what do we mean by nonlinear simultaneous equations? Well, these are situations where at least one of the graphs of the equations doesn't form a straight line. There are two situations that frequently come up in Gcse questions. The first is if we have a quadratic graph, so something that looks like this, and then also a straight line graph. You can see that there will be two solutions to these simultaneous equations because the graphs cross in two places. The second situation is if we have a circle, and once again a straight line. You can see again this one has two solutions because they cross in two places. For both of these graphs drawn, you can see there were two solutions because the graphs intersected twice. But this isn't always the case. For example, on the left-hand graph here, you can see this line is a tangent to the graph. This means it only touches in one place here. You can have the same situation with a circle like this. It's even possible to have no solutions. This corresponds to a situation where the graphs never cross, so a straight line like this, or like this. So how can you identify from the equations if it's non-linear? Well, you're usually looking for something like an x squared or a y squared, so higher powers of x or y, or sometimes xy's times together, like this. If any of these are present, you can be sure it's not going to be a straight line graph, so it is a non-linear simultaneous equation. In this video, we're going to solve 4 sets of these equations with slight differences between each one. In all of the questions though, we're going to use the same general strategy. We want to eliminate one of the variables, so we end up with an equation that's just in the other variable that we can solve. In this first question, both of the equations have been written in the form y equals. This makes it relatively easy to eliminate the letter y. If y is equal to x squared plus 10x plus 6, but also y is equal to 4x minus 3, then we can simply write x squared plus 10x plus 6 equals 4x minus 3. We can now see we've got an equation in x and there are no y's. We can solve this equation in our usual way. So this is a quadratic equation. We need to get all of the terms on the left hand side and set the right hand side equal to 0. So let's subtract 4x from both sides first. On the left hand side we'd have x squared, then if we take away 4x from 10x we get 6x, and then plus 6, and then if we take away 4x from the right hand side we'll just be left with negative 3. Then we can add 3 to both sides. On the left hand side we'll have x squared plus 6x, and then we've got 6 plus 3 which is 9, and on the right hand side negative 3 plus 3 is 0. Fortunately, this one will factorize. It will factorize into the brackets x plus 3 equals 0. Since both of the brackets are the same, this leaves us with just one solution, x equals negative 3. This means that if we drew the graphs of these out, they would only touch in one place. Now we need to get the corresponding y value. So we can go back to either of the first two equations and substitute this x value in. It's almost always going to be easier to substitute into this one here, the linear one. So we would say when x equals negative 3, y is going to equal 4 lots of x take away 3, so y will equal 4 lots of negative 3 take away 3. 4 lots of negative 3 is negative 12, and then take away 3, and that gives you negative 15. So we end up with one solution to these simultaneous equations. It's when x equals negative 3 and y equals negative 15. In this second question, things are a little bit different. Firstly, we've been asked to find the coordinates of the point of intersection for the graphs. This still means we just need to solve the equations, but we must write our answers as coordinates rather than pairs of values of x and y. The second difference is the structure of the equations themselves. If you look at the first equation, it's in the form y equals, but the second one isn't. So we're going to rearrange this second equation so it is in the form y equals. On the left hand side I've got y plus 4x, but I would rather that 4x wasn't there, so I'll subtract it from both sides. On the left hand side I get just y, which is what I want, and on the right hand side 8 take away 4x. So I can change that equation with this one here, which is exactly the same equation, but it's now written in the form y equals. You can see both of them are in that form now, so we can carry on as we did with the first question. So 2x squared minus 17x plus 14 is going to equal 8 minus 4x. We now just solve this quadratic equation again. So we want all of the terms on the left hand side and the right hand side to be equal to 0. So we're going to add 4x first. On the left hand side that gives us 2x squared. Negative 17x plus 4x is negative 13x. And then plus 14. And on the right hand side, if we add 4x to negative 4x, that cancels, so we're just left with 8. Now we need to subtract 8 from both sides. This will give us 2x squared minus 13x, and then 14 take away 8 is 6, and 8 take away 8 on the right hand side is 0. Now we've got the quadratic equation to solve. This one will factorize again, it's a little bit harder to spot, but it will be 2x minus 1 and x minus 6 equals 0. This will give us two solutions this time. So the first bracket, 2x minus 1 equals 0, means that 2x would equal 1, and therefore x would equal 0.5. For the second bracket, it's straightforward, x will need to equal positive 6. So our two solutions for x are x equals 0.5 and x equals 6. But we also need to get the corresponding y values for both of these solutions. So again, we're going to substitute them into the linear part here. So when x equals 0.5, y will equal 8 take away 4 lots of that, so 4 lots of 0.5. 4 lots of 0.5 is just 2, so y equals 8 take away 2, and 8 take away 2 is 6. So when x equals 0.5, y will be 6. Now we do this with our second solution when x was equal to 6. So when x equals 6, y is going to equal 8 take away 4 lots of 6, which is 8 take away 24, and 8 take away 24 is negative 16. So when x equals 6, y equals negative 16. Now we have our solutions, but remember the question said to find the coordinates of the points of intersection. So all we need to do is write our solutions in a coordinate form. So we've got x equals 0.5 and y equals 6. If we write that as a coordinate, it's 0.56. And we've also got x equals 6 and y equals negative 16. And as a coordinate, that's 6, negative 16. In this question, things are different once again. In the last two questions, we got the equations in the form y equals and then set them equal to each other. In this question, the second equation is in the form y equals, but the first one isn't. In fact, the first one has a y squared, which is something we haven't come across yet. We approach these in a slightly different way. So what we're going to do is rewrite out this first equation here, but since y is equal to 2x minus 15, whenever we get to a y, we're going to write 2x minus 15 instead. So we're going to substitute y out for 2x minus 15. So let's start writing the first equation. It's x squared plus y squared equals 50. But instead of that y, we're going to write 2x minus 15. So let's lose the y and write 2x minus 15. And of course, since it's y squared, that needs to be squared. So we've now substituted the y out. You can see we've got an equation just in x. There's a little bit more work to do on this one though. Let's first of all focus on this bracket squared. So we've got x squared plus this bracket squared, which means times by itself. So we've got 2x minus 15 times by 2x minus 15 equals 50. So let's write the x squared. Then we're going to expand this double bracket and write all of the terms inside this big bracket equals 50. So what do we get if we expand this double bracket? Well, we've got 2x times 2x, that's 4x squared. 2x times negative 15, that's negative 30x. Negative 15 times 2x, that's also negative 30x. And negative 15 times negative 15 is positive 225. Inside the bracket, we can simplify these two terms here. That's negative 60x. And then since the bracket is just added to x squared, we can lose the brackets. So we get x squared plus 4x squared, that's 5x squared, and then we've got minus 60 plus 225 equals 50. So we've ended up with a quadratic equation again. We're going to get the right hand side equal to 0, so we need to subtract 50 from both sides. So we have 5x squared minus 60x, and if you subtract 50 from 225, you get 175. And if you subtract 50 on the right hand side, you get 0. Now this quadratic equation looks quite scary, especially if I said to factorize it. It is possible, but we can make it much easier. Notice how all of the terms have a common factor of 5. This means we can divide by 5 on both sides. If we divide by 5 on the left hand side, rather than 5x squared, we just get 1x squared. And then negative 60 divided by 5 is negative 12, so negative 12x. And 175 divided by 5 is 35. And on the right hand side, you also have to divide by 5, but 0 divided by 5 is still 0. So we can solve this quadratic equation instead. This one will factorize really nicely. It's x minus 5, x minus 7 equals 0, which gives you two solutions. X equals 5 and x equals 7. So now we need to substitute both of these back in to get our y values. Again, we'll go for the linear one. So when x equals 5, y is going to equal 2 lots of x, take away 15. So y will equal 2 lots of 5, take away 15. 2 5s are 10. So 10 take away 15. And 10 take away 15 is negative 5. Then we do the same thing for when x equals 7. So when x equals 7, y will equal 2 lots of 7, take away 15. 2 lots of 7 is 14, so 14 take away 15. And 14 take away 15 is negative 1. So we've now found the two solutions. We've got the first one when x equals 5 and y equals negative 5. So x equals 5, y equals negative 5. And the second one was when x equals 7, y was negative 1. So when x equals 7, y equals negative 1. And now on to the final question. So a bit like the last question, this one's got some x squareds and y squareds again. So we're going to use a similar approach to the one we did in the previous question. In the previous question though, the second equation was in the form y equals. So we're going to need to do some rearranging first because this second equation isn't in that form. In fact, it's actually easier to rearrange the second equation so it's x equals. In all of the previous questions, we've eliminated y and ended up with an equation in x to solve. But it's also completely fine to eliminate x and end up with an equation in y to solve. The reason it's easier to substitute out x in this one is because we have 1x, whereas you can see for the y's it's negative 2y. So let's take this second equation here, and let's rearrange it to make x the subject. To do this, we just add 2y to both sides. On the left hand side, then we've got x, and on the right hand side, we'd have 1 plus 2y. So this is the rearranged version we're going to use. We're now going to rewrite the first equation out, but everywhere where we get an x, we're going to write 1 plus 2y, because in the second equation we have x equals 1 plus 2y. So let's remove that x squared, and in its place, put 1 plus 2y squared. Now we have an equation in y to solve. So the first bit is a bracket squared, so that's the bracket times by itself. And then we have minus 5y squared equals 4. Now let's expand this double bracket. So let's start with 1 times 1, which is 1. 1 times 2y, which is 2y. And 2y times 1, which is also 2y. And then 2y times 2y, which is 4y squared. And then we've got minus 5y squared equals 4. There's a bit of simplifying we can do on the left hand side. So we have 1, and then we've got plus 2y, which is plus 4y. And then we've got this 4y squared minus 5y squared, which is negative 1y squared, and then equals 4. Now, just like before, we're going to get all of the terms on the left-hand side and make the right-hand side equal 0. So let's subtract 4 from both sides. On the left-hand side, 1 take away 4 is negative 3. Then we've got plus 4y minus y squared. And of course, 4 take away 4 on the right-hand side gives you 0. Now this quadratic will factorize, but the negative y squared doesn't make things easy for us. But there is an approach we can use. We could either add all of those terms to both sides so that the left-hand side was 0 and the right-hand side had all of the terms, or we could multiply both sides by negative 1. If you multiplied the left-hand side by negative 1, you get all of the same terms, but the signs will change. So instead of that negative y squared, we get a positive y squared. Instead of positive 4y, we get a negative 4y. And instead of a negative 3, we get a positive 3. And if you multiply the right hand side by negative 1, well 0 times negative 1 is still 0. This quadratic's now in a much nicer form and it will be easier to factorize. So to factorize this one, I need y minus 3 and y minus 1 equals 0. And this gives you two solutions for y equals 3 and y equals 1. Now we have our y values, we'll need to work out the corresponding x values. So I'm going to substitute those back into the second equation, x equals 1 plus 2y. So when y equals 3, x is going to equal 1 plus 2y, so x equals 1 plus 2 lots of 3. So x equals 1 plus 6, and 1 plus 6 is 7. Then we do the same for when y equals 1. So when y equals 1, x is going to equal 1 plus 2 lots of 1. And 1 plus 2 lots of 1 is 1 plus 2. And 1 plus 2 is 3. Now, like the second question, this also asks for the coordinates of the points of intersection. So we'll need to write our solutions as coordinates. So we've got the first one here with y equals 3 and x equals 7. You need to be really careful and make sure you get the coordinates the right way around, since we found the y values first. But when you write coordinates, you write the x value first. So the first solution will actually be 7, 3, rather than 3, 7. And for the second one, we had y equals 1 and x equals 3. So the coordinate here is 3, 1.